All right, the following is the walkthroughs for some of the questions in Chapter 16. Let's take a look at Chapter 16, question number 18 first. And in this example, we're looking at a hockey team called the Penguins. They play in the North American Ice Hockey League. And what we're told here is that the venue that they play in has capacity of 15,000 seats, of which 5,000 are in the lower tier, 10,000 are in the upper tier. They're told that there is some cost that is charged for the use of the facility, so there's some variable costs that are given to you. And what we're told here is that the selling price is $35 and $14, depending on if the tickets are sold in the lower tier or lower bowl, and then in the upper bowl. Now, again, $35 and $14, so we're not talking about the Canucks here, but what we are talking about is a contribution margin of $20 and $5 respectively. I want you to think about that, though. If you're thinking about putting on a hockey game, the tickets for the the costs for the team would be fixed. The cost to hire the people to put on the event would be fixed. Even the concession, really, I mean, depending on the number of people that are there, we'd still have to pay their salaries no matter what. So proportionately, we'd make a lot more money if we sold more tickets in the lower bowl, where the contribution margin was higher, than if we were to sell tickets in the higher seats. What we see here is that we budgeted for 4,000 and 6,000, or 40 and 60% of the tickets to be sold in the upper and lower tier respectively. Now, we ended up selling 11,000 tickets, so this is good, right? We sold more tickets than we expected to sell. But if we look proportionately, we're at 3,300 seats and 7,700 seats, and I believe that works out to 30 and 70% respectively. So here the mix isn't what we expected it to be, and we're probably going to see that this is now going to be an unfavorable variance in terms of the mix, because we're selling more of the contribution margin tickets that are lower, right? More of the $5 tickets as opposed to the ones that are $20. What we're told to do in this question is to work out the sales volume variance, and then work out the sales quantity and sales mix variances for each type of ticket, and then summarize all of that together. Okay, so to do this, let me get some blank paper here. One quick second. Okay, so we've got ourselves some blank paper, we've got ourselves a pen, and we aren't going to do this for all of the tickets, but let's certainly walk through the lower bowl or the lower tier tickets first, and then we'll take it from there. So here's our lower tier. Now, what we're going to do is we're going to start out with the actual company volume. And our actual company volume was 11,000 tickets. Our actual mix, we can work out to be 30%, and the way we get this number is by working backwards from the fact that we sold 3,300 tickets. Okay, so we were told we sold 3,300 tickets. We're also told that the actual contribution margin was $20. So 3,300 times $20 gives us $66,000. Okay, and if we go down the middle post now, we're going to take our actual company volume again, which is 11,000 tickets. Our actual mix was still 30%, but here what we would do is we would put our standard contribution, which in this case in the question was told to us as $20 as well. So this is our standard, my apologies for putting this backwards here, this is our standard contribution. Now in this case, we're not going to get a variance between here and here, and this would be your flexible budget variance. But here the standard and actual contribution margins were exactly the same, so we don't see a variance here. What we're interested in primarily in this course, though, is this variance on this side. We're looking here at the sales volume variance. Okay, this is called the sales volume variance. And what we're going to do to work it out is up at the top here, now we're going to put our standard company volume. And that was 10,000 tickets. We're also given our standard mix, and we're going to work backwards to figure that out, because we know that our standard CM, or our standard number of tickets sold, was 4,000. If that's 4,000, how much was our standard mix? It must have been 40%. Right, so just working backwards, we get to 40%. 4,000 tickets at $20 a ticket. This is our standard contribution margin here. Gives us a total of $80,000. Okay, and so the sales volume variance here is an unfavorable variance of $14,000. And it's unfavorable because we would have expected to have a total contribution margin of $80,000 when in fact we only earned $66,000. Now the question we need to figure out is, well, why is there a $14,000 unfavorable variance? Is this primarily due to the number of tickets we sold, or is this due to the mix, or is it some combination of the two? So what we're going to do is we're going to drill down into the lower tier here and try to explain out that $14,000 unfavorable variance. And we're going to do that by looking at our two level 2 variances. And those are the mix and the quantity variances. Again, starting out with our actual company volume on this side. So our actual company volume was 11,000 tickets. We're also told that the actual mix was 30% and that the actual number of tickets sold was 3,300 tickets. We're told that the standard contribution margin was $20. Okay, so down this side here we're at $66,000. Now one thing I'd like you to notice is that everything along the bottom here is still going to be standard contribution margin, because if you look between here and here, everything's at standard, right? So this is at standard contribution, this is at standard contribution, and it follows that if we drill down, everything down along the bottom here is also going to be at standard contribution. So if we look, this is still standard, and even this one here is going to be at standard. All right, so we'll put 20 here and 20 here. Now this first variance we're going to look at is our mix variance, and the reason it's called the mix variance is because we're going to vary the mix. So again, up at the top over here we're going to put our actual company volume, and that's still 11,000 tickets, okay? And our actual mix was on this side, which means this one needs to be our standard mix. And our standard mix of tickets would have had us sell 40% in the lower tier. Now, if we were to have sold 40% of our tickets in the lower tier, we would have expected to sell 4,400 tickets. And if we did, this would have been $88,000. So what we see here is we've got a fairly large unfavorable variance of $22,000. And it's unfavorable because the mix shifted away from the tickets that made us more money. And in fact, we ended up selling more tickets in the upper bowl. Now, on the other side, we've got our quantity variance. Quantity. Okay. And our quantity variance here was, well, let's work it out. Our standard company volume. So notice here we're varying the quantity. Would have been 10,000 tickets. We're going to hold mix constant at 40%, and that's our standard mix. Okay, so on this side, notice here that our actual, and this is standard, so we're varying the volume here from 11,000 down to 10,000. So this would have been 4,000 tickets, and we see that this is $80,000. So here we actually have a favorable variance of $8,000. And the reason it's very favorable is we sold more tickets than we expected to sell. Okay, so I'd like to point out a couple of things here. If we take these two variances together, minus 22,000 plus 8,000 reconciles back to the $14,000 unfavorable variance that we saw earlier. And again, this is just to point out that all we're trying to do here is to explain away that $14,000 unfavorable variance, and we're doing that by showing that the mix actually shifted well away from what we expected it to be, but we did sell more tickets than we expected. And if we go back to the facts in the question itself, we see that there is a declining economy, so it would make sense that people are going to buy the cheaper seats. Okay, now we would do this again for the upper tier, and rather than do that here in Excel, or sorry, in OneNote, let me just show this to you in Excel and walk through what's going on here. So in our upper tier, we're going to do exactly the same thing that we just saw here. Our actual company volume is 11,000. Our actual mix, well, we actually sold 7,700 seats, and we can work backwards to get our actual mix of 70%. At an actual contribution margin of $5, this gives us $38,500. Okay? Now again, we don't have a flexible budget variance here because we're told that both the actual and the standard contribution are $5. What we do have is a sales volume variance, and that's because here our actual company volume is 11,000 compared to our standard company volume, which is 10,000, and our actual mix is 70%, and our standard mix is 60%. So our overall variance here is 8,500, but we want to know what's causing that variance to happen. Like, was it due to the mix or was it due to the volume? And you'll notice that on the middle post there and on the far right post, we're changing both the mix and the volume at the same time. So we've got to drill down again to level 2 to figure out what's causing what. On the mix side, we're going to see that we expected a mix of only 60% when we actually had a mix of 70%. So here we've got a $5,500 favorable variance. On the right hand side over here, holding mix constant at 60%, what we're going to vary instead is our actual versus our standard company volume. And multiplying that out, what we get is 33,000 down the middle and 30,000 on the right hand side, giving us an overall variance here of another $3,000 favorable. Adding those together, we get an overall variance of $8,500. Now, all of this taken together, I think, is where this gets to be quite interesting. We notice that in the lower tier, we had a $14,000 unfavorable variance. In the upper tier, we had a ticket variance of $8,500. So our overall sales volume variance for the two tickets combined is $5,500. And again, that's unfavorable. If we look at the mix and the quantity variances together and we add them up, we'll notice that those also reconcile to $5,500. And I've left you a note here that says this must equal the sales volume variance, which it should. Okay. Let's take a look at another question here. The next one we're going to look at is a lot more complicated in the sense that there's a lot more products, but the approach we're going to take is exactly the same. Again, we've got another company. This one's called Blank Slate Inc., and they produce tablet computers. What I'd like you to notice here is that the three tablets have very different selling prices. One sells for $379, one sells for $269, and one sells for $149. We see that the contribution margin is favorable for each of them, or positive for each of them, so we are making money per unit sold. The question is then, well, how did we do? Like, how did we do compared to budget and so on? What we are told here is that our budgeted data gives us $197 on the Slate Pro in contribution, the Slate 171 and the Slate Lite $84. What we actually saw happen here is that the Slate Pro earned us $171, the Slate $193, but the Slate Lite, if you take a look, it only earned us $29 in contribution. So here, if the mix heavily shifts in the favor of the Slate Lite, what we would expect to have here is then an unfavorable mix variance. And if we take a look at the proportion of what we sold, we see that we expected to sell 12,500, 37,500, and then 50,000 of the products. And instead what we sold is actually 55,000 of these things here, out of a total of 110. So we'll have to see what that does in terms of each of the variances here. What we're given as instructions here is to compute the actual and budgeted contribution margins in dollars for each product, then calculate the actual and budgeted sales mixes for the three products, to work out the sales volume, sales mix, and sales quantity variances, and then finally, given that your CEO is known to have temper tantrums, you want to be well prepared for the meeting, and in order to prepare, write a paragraph or two comparing the actual results to the budgeted amounts. So let's take a look and see what's going on in this question. For this one here, we are going to work in Excel. I'm going to work on simply one of the products, and then we're going to work out and take a look at a little bit more quickly the other two products, because again, it becomes more of the same. Okay. Where am I here? There. Okay. So let's take a look at the Slate Pro, and we're going to start there because I think it's fairly straightforward. Our actual quantity sold was 110,000. Our actual mix, well, we know we sold 11,000 of them. So if we work backwards, 11,000 divided into 110,000 gives us 10%. At an actual contribution margin of 171, we get 1,881,000 on the left-hand side here. Down the middle, what we see is that our standard contribution was 197, and when we look at the impact that that has to our flexible budget variance, we get a negative variance of $286,000. And again, that's simply because our actual contribution was budgeted to be, our standard contribution margin was budgeted to be 197, and our actual was only 171. On the sales volume side, again, we've got an unfavorable variance here. Now, that's because our standard quantity was 100,000, but our standard mix was 12.5%. And regrettably, our actual mix ended up being only 10% of 110,000. So the total volume we ended up selling was 11,000 tablets, compared to the 12,500 tablets we expected to sell. Holding contribution margin constant, this gives us an unfavorable sales volume variance of $295,500. So we need to see, was that because of the quantity, or was that because of the mix, or is it a combination of both? Okay, so let's drill down. If we take a look here at the Slate Pro, again, the most important thing I would like to point out very quickly here is from a memory perspective, this is at standard, this is at standard, and this is at standard. Okay? On the mix side, we are varying the mix from 10% to 12.5%. On the quantity side, let me just switch colors here one more time, we're varying the actual quantity compared to the standard quantity. Okay, so if this helps you memorize or learn this stuff, keep in mind, here we're holding mix constant, but varying the quantity. And on this side, we're holding quantity constant, but varying the mix. Okay, so I hope that's clear. Again, on this side, we are holding the quantity constant at 110, but notice we're varying the mix from 10 to 12.5%. So this tells us that as a result of selling proportionately less of these tablets, we get an unfavorable mix variance, and I should have done this in the other color. We get an unfavorable mix variance of $541,000. Whereas on this side, holding mix constant, we see that we expected to sell 100,000 of these things, but we ended up selling 110,000 of these things. So this gives us a favorable variance in terms of quantity. Okay. If we take a look now at the Slate, and again, there are 3 products. I'm not going to spend a whole ton of time doing this 3 times in a row. What I do like to point out here, or what I would like to point out here, is that the flexible budget variance is favorable. And the reason for that is our standard contribution margin was 171, when in fact we actually earned $193 on each of these that we sold. So this gives you a favorable flexible budget variance. And what we're also going to see here is that the standard mix and quantity were 100,000 and 37.5% respectively, when in fact we actually sold even more and at a higher mix. So this is good. We get a favorable variance of $1.1 million, but we have to see, well, okay, how much of that was due to the fact that the mix shifted in our favor, and how much of that was due to the fact that the quantity we sold also shifted in our favor. So let's drill down. The mix variance, again, holding actual quantity constant, we're not going to vary it, and by varying the mix from 40% to 37.5%, we get a mix variance of $470,000. On this side, holding quantity constant, but now varying, holding the mix constant, but by varying quantity from 110 to 100, all at standard contribution, here we get a quantity variance of $641,000. Okay, so both are favorable, but we've now isolated how much of that overall change was due to mix and due to quantity. 641 was due to quantity, 470,000 was due to mix. Taken together, they give you 1,111,500. And again, just keep in mind that this number reconciles to that one up there. Okay, we would then do it again for Slate Light. The one thing I do want to draw your attention to for Slate Light is we've got a massively unfavorable flexible budget variance here, and we don't spend a lot of time looking at that in this class. But the reason that we've got such a major flexible budget variance that's so unfavorable is because our contribution margin dropped way, way down. Okay? The other thing I'd like to point out, though, is that the quantity variance is actually favorable, right? We've got $420,000 in our quantity variance here because we sold more than we expected to sell, but proportionately, our mix variance is actually constant. We sold 50% of our sales in this product, and we expected to sell 50% in this product. Alright, so just like we saw before, you can summarize your level 1 and your level 2 variances. And when we do that, we can start to explain away why we earned what we did, okay, and where we ended up spending a lot of our money. The flexible budget variance, I think, is the one thing to really look at here, especially for Slate Light. We've got a $3 million unfavorable variance, and again, part of the reason for that is simply because we ended up making a lot less money than we expected to make for every unit sold. Now, if we look at question number 28 in the book, what it's going to ask us to do is to then drill down even further to look at market size and market share. Let me see if I've got this question screen capped, and I do. So what this says is that Blank Slate Senior Vice President of Marketing prepared the budget at the beginning of the third quarter and assumed a 25% market share based on total sales. They expected a market of 400,000 units, but actual sales were actually 500,000 units in the same period. So what we're asked to do is to work out both the market share and market size variances for this company. For us to do that, we're going to work out a weighted average contribution margin. Now, your book calls this something particularly complicated. There's no need to complicate it that much. All we're really talking about here is if you've got a number of different products, how do we then describe and talk about changes to the overall market size and market share if we've got a number of different products that we sell? Now, for us to be able to do that, we need a way to talk about all of the different products we sell, and let me just show you how we're going to do that. I need to point out some key numbers here for us to be able to make that happen. I want you to notice here for Slate Light that down the far right post, so everything at standard, we would have expected a contribution margin of $4.2 million. That's at standard quantity, standard mix, and standard CM. Keep that number 4.2 million in mind. For the Slate, we were at $6,412,500. Again, we're on the far right post here. And finally, for Slate Pro, we're at $2,462,500. Okay, so keep those three numbers in mind. $2,462,000, $6,412,000, and then $4.2 million. If we add those three numbers together, and again, take my word for it, that this formula is adding those three cells together. And I'll just show you. That's 4.2 million there, 6.4 million there, and then the 2,462,000 up there. When we add those all together, we get effectively a total contribution margin that we would have expected across all of the products we sell, and that gives us $13 million. If you add up the standard volume for all of those products, we would have expected to sell 100,000 of them, and this gives us a weighted average contribution margin of $130.75. Now, what that really means is it gives us a way to talk about sales of all of our products at the same time. Okay, now why that matters is because if we look at the total sales quantity variance for all of the different products that we sold, we were at $1,307,500. What we want to do is now drill down even further to explain that in the context of both market size and market share. Okay, the way we're going to do that is we start by looking at our actual industry sales of 500,000 units. Okay, now we were told that our company volume was 110,000 units, and we were celebrating that by looking at our favorable quantity variances. Okay, but when we look at it, that actually works out to a market share of only 22%. Now, multiplying the 110,000 units we sold by the weighted average contribution, we get $14,382,000. If we were able to maintain a market share of 25%, what we would have ended up earning, at least from a budgeted perspective, was $16 million. Now, looking at those two numbers together, we get an unfavorable market share variance of $1,961,250. But the market did grow, right? The market grew much bigger than we expected it to be. We expected 400,000 units total in the market. We actually saw a market that was 500,000 units large. Okay, what did that do for us? Well, if we look and multiply this out, holding now our market share constant at 25%, we see a favorable variance of $3,268,750. Add that to your unfavorable market share variance, and we get $1,307,500. So we've explained away the overall sales quantity variance. It's not that the variance is just favorable because we did anything special. All that really happened is that the market itself grew, and management really was unable to maintain their market share. So here, if I was the CEO, I'd be looking at my marketing manager and asking them, well, why were you unable to maintain the market share that you should have maintained? Okay. So that's that one. The next question we're going to look at is 16-19. The Guangzhou Corporation, and they sell two brands of wine glasses, plain and chic. What's interesting about this question is you actually have to work backwards to solve it, and this one's a little bit challenging, so we're going to go through this more slowly than we typically have done with some of the other problems that we just looked at. Okay, so just give me a quick second here to grab some notes, and we'll get right into this here. Okay. We are going to actually have to solve a couple of systems of equations to get through this question, and again, we're going to work through it slowly, so let's do it. The Guangzhou Corporation sells two brands of wine glasses, plain and chic, and then they give you the following information. Our static budget total contribution margin is $5,600. The budgeted units to be sold of all glasses is 2,000 units. So again, that's not just of one type of glass, it's of all of the different glasses together. Our budgeted contribution margin for plain is $2, and for chic is $6, and our total sales quantity variance is $1,400 unfavorable. We're actually also told the sales mix percentage of plain, and that's 60%. It asks us to calculate the sales quantity variance for each product in June, and then the individual product and total sales mix variances in June. And then, anyway, it asks us to then compare or calculate the individual product and total sales volume variances for June as well. Alright, so for us to do that, I think it makes sense to lay out our grids and see what information we have and then what information we still need. If we're looking at plain, what we are told is that the actual company volume is unknown. We don't know what that is. We do know that the actual mix, is that given to us? Is 60%. So we are told that this is 60%, and that will help us soon enough. But for now, we don't know much more than that. Our actual product volume is not known to us either. What we do know is that the standard contribution margin is $2. Now, why am I doing this at standard? Because what I'm going to do down here is I'm going to look at the mix variance. Okay, so we're down at level 2 anyway. Again, at level 2, I am going to need to know my actual company volume. And we still don't know that yet. Here I'll put my standard mix. And I do need to work that out in just a second here, and we can do that, I think. I also need to put my standard contribution, and that was $2. Okay, so we don't know much else yet. Let's see if we can complete the right column over here, and then we'll go forward from there. So here we've got our standard company volume. And were we given that information for all products? We were told that we expected to sell 2,000 units. So we do know that this is 2,000. We also want to put our standard mix over here. Okay, we're going to put a percentage. And then we need to put our standard product volume. And do we know how many units we would have expected to sell? Again, no, it doesn't really tell us that. It doesn't tell us our standard product volume either. But we know that this is going to be our standard CM, and that's going to be $2. Okay, well, why we need that is so we can solve a system of equations here to, I think, hopefully tell us some information about what we should have earned and the number of units we would have expected to sell and so on. Setting this up, what we have here is the amount of contribution we earned on Plane, and if we know that Plane sells for $2, well, the number of units of Plane that we sell, let's let that equal to X. If we add that to the number of units of Chic that we sell, and given that these are the only two products that we sell, Chic sells for $6 in terms of its contribution margin, and if we were told, I think, that the total number of products we expect to sell is 2,000, right, that's this number here, then it would follow that the number of units of Chic we sell would be the 2,000 minus whatever we sold in Plane, right? We only have two products. If X is the number of units of Plane we sell, then the number of units of Chic we sell would be 2,000 minus X. When you add those up, what that's going to give us is our total contribution margin, which I think was told to us in the question is $5,600. And again, going back to the question, I can show that to you. It's our static budget total contribution margin of $5,600. Okay, so we put those two numbers together. What that's given us is a nice little equation here that we can then solve. And what we get if we solve for X is 1,600 units of Plane. And therefore the number of units of Chic will be equal to 2,000 minus the 1,600, which is 400 units of Chic. Okay, now what that allows us to do is to work out a percentage. We've got our standard mix then of Plane, and that's the 1,600 units out of the total of 2,000 units, and that gives us 80%. And then the standard mix of Chic would be 100% minus the 80%, which is 20% Chic. Or you could just say 400 over the 2,000 units. So we've got 80-20 going on over here. We can come back to what we were setting up earlier. And here we were talking about Plane, so this is going to be 80%. 2,000 times 80% gives us 1,600 over here, and this means this number down here is 3,200. Okay, we still don't know our actual company volume, so we still have some work that we have to do to solve that, but we're getting closer. We're starting to get some information that will help us hopefully solve this. And keep in mind, this is your SQV on this side. Okay. So this is for Plane. Let's see if we can set up Chic, and then let's see if we can solve this problem. And I need a bit more space over here, so let me just move that down. For Chic, let's do that. For Chic, what we have over here is as follows. Our actual company volume is still unknown to us. Our actual mix is also unknown to us. Our standard contribution margin is $6, so that's helpful. Down the middle, again, we need our actual company volume, which we still don't know. On this side, we're going to have our standard mix, which we do know is 20%. Right, so again, that's fairly helpful. And our standard contribution margin down here is $6. Okay, so we're still not done. On the far right side over here, we have our standard company volume of 2,000. We have our standard mix of 20%, 2,000 times 20% gives us 400. At $6, which is our standard CM, we get 2,400 on this side. Okay. I think we're getting a little closer at this point. We're not quite done yet, but we do need to start putting all of this information together. Now, if we look, what we can now set up is that 3,200 plus 2,400 on the far right over here gives us, what is that? 5,600. And we know that that was our total contribution anyway, so the numbers do check out. Were we told anything else in this question here? And we were told that the total sales quantity variance was 1,400 unfavorable. So that would be the sales quantity variance for both products here. If I add up this one and this one, so this number plus this number, I'm going to get 1,400 unfavorable. If that's 1,400 unfavorable, we can then say that this must be $4,200. Right? That's the only way we're going to get a $1,400 unfavorable variance. If this is 5,600 and that's 1,400 unfavorable. Okay, so that becomes a very useful piece of information for us, because now what we can start to do is to work out a little bit more. Because if we take X, which is the actual company volume, times 80%, times $2, and we add that again to our actual company volume times 20%, times $6, we get our variance of $4,200. If we solve for X here, we get 1,500. So now we know our actual company volume is 1,500. Bringing that number back into where we were before, we can now solve most of this by putting 1,500 here, 1,500 here, 1,500 here. Our actual mix was also known to us, and sorry I didn't write this in earlier on, but that should have been 40%. So up at top over here, we've got 1,500 times 60%, and that gives us 900. 900 times $6. I'm sorry, I'm in the wrong spot here. 1,500 times 40%, my apologies, is 600. 600 times $6 gives you 3,600. Up over here, 1,500 times 60% is 900. 900 times 2 is $1,800. So if this is 1,500 times 80%, that's 1,200. 1,200 times 2 is 2,400. And we can see that this now starts to unravel. If that's 2,400, this gives us a $600 unfavorable variance in terms of mix. On the far right, 2,000 times 80% times 2. We've got the 3,200 on the far right over there. Down in the middle, we've got 2,400. And this gives you an $800 unfavorable variance. Okay, if that's 800, and this far right side is far left side is 3,600. This is 1,500 times 20%, so that's 300 times 6 is 1,800. 1,800 compared to 2,400 gives you a $600 unfavorable variance. Let's just make sure that all of this is working. Is 800 plus 600 1,400 unfavorable? And it is. So this is working out for us just fine. And finally, the last variance we're going to look at is this one over here. This is 3,600. This is 1,800, and this gives you a $1,800 variance. So our actual mix was supposed to be 20%. It was actually 40%. So this is a favorable variance. Now I'd say this is a fairly challenging problem because you actually do have to work backwards and try to figure out what information you have compared to what information you're missing, and then solve for the missing information. I also think it's a fairly good question because it does allow you to then work backwards and find information that you may not have had in the question itself.